So good evening everyone and welcome to this lecture. Hopefully we will be able to wind off your electric field in today's class and what we were doing in the previous one. Okay, we were trying to solve problems based on electric field of an infinite sheet. We had seen some problems. We had seen the problem of that projectile and we had also seen the problem of this gentleman which we had done in the first class also. We had seen these problems, right? So we'll go ahead and what? And I will. Where is that problem? Yes. Now you can have a variety of problems. You can have a variety of problems on this, and most of the problems that you are going to face in the exam would be on infinite sheet because that is one of the hot topic these days. So let us tackle those problems. If you can do one or two of them, then then I can stay in peace that you are able to do them. Now for example, if this is a problem, what is the problem? The problem is very simple. I have a infinite sheet. It has a Q1 charge on one side and Q2 charge on the other side. What is the electric field at point P? Huh? I hope everyone understands the question. The question is pretty straightforward. And this question is done for a very specific purpose so that I can make you understand a point which will probably help you in solving some other questions. Yes. What is the answer for this one? Huh? No one knows this. Everyone is looking at each other's faces. Remember, answers are never on the faces of your friends or your class teachers. The only way you
Sigma
can
by 2 epsilon naught, sir.
sigma. What is sigma? I don't know sigma. Charge is given as Q1 and Q2. We are still living in the fantasy world. Charge is given as Q and the area you can take it as A. Area of the plate you can take it as A. Yes. Can I have the answer? Huh? So remember, anyone has the answer? No, sir, we don't have the answer, sir. So the answer is pretty simple and pretty straightforward. It will be Q1 plus Q2 divided by 2 times A epsilon naught. What is the important thing that you must understand about questions of this type is that the charge due to a plate does not depend on the what? The distribution of charge on the plate. There could be Q1 charge on one side, Q2 charge on the other side. It does not depend on how much charge is on which side. It only depends on the total charge of the plate. So that is what you got to remember, because in very few classes, maybe one or two classes, we will be coming across plates. In fact, from the next question also, I can show you that we'll come across plates which will have different charges on the different sides. On one side it may have different charge and on the other side it will have different charge. But what you got to understand is that electric field created by a plate does not depend on the distribution of charge. It only depends on the total charge. The total charge divided by 2a epsilon naught. Do you understand this? It has gone above at saying bye bye. Bye bye, sir. I'm going.
Understood, sir.
Okay. So remember this does not depend on the distribution of charge. Now, this question, normally I do it after we are done with a lot of things, but every day you learn something new. So I always try new things in new life, and this is probably the first time I'm doing this question at this point in time. I don't normally do it at this point in time. Now I have 3 plates. The surface area of each plate is given as A. One plate is having charge plus Q. The other one is having minus 2Q. The third one is having charge 3Q. Now this question will come again when we try to wind up this chapter. Maybe before that. It will come very soon again. Then again we will do it, but probably we might do it in a different way. Different way is not different. We will just do it in a understanding something else. The question right here, right now is what is the electric field at the point A, B, C, and D? That is what we are concerned about right now. So I'll give you a couple of minutes. Think about it. Get the answer and stay happy. Remember, it's a simple question. Every question that comes is simple. Any question that is difficult will never come. It's a simple question with a simple concept and a simpler answer. Yes. Eh? No one gives the answer. Give me the answer for anyone. I'm not expecting answer for all. At least tell me the electric field at point A. Who can tell me the electric field at point A? Eh? No one. Shameful, shameful. Arey, tell me. Answer may be right, answer may be wrong. Not worried about the answer. Huh? Hey, do you know how to do it or shall I do it? I am just giving you time and everyone is chilling out.
Sir.
Yes. What is the electric field at point A? Yes. Eh? I did not get the answer. I only got yes.
Q by 4 epsilon.
Q by 4. No, Q by 4 is not correct. Q by 4 is not correct. Q by 4 is not correct. How did you get Q by 4, by the way? Just like that, sir. कभी कभी मेरे दिल में ख्याल आता है. So I gave this answer because of the thoughts in my head.
2 pi 2 pi epsilon naught.
Okay. What I'll do is I'll do one for you, and then I would expect that you can replicate. Remember, no one clears JEE in the examination hall. The JEE is cleared right now in the class. So what we are doing is clearing JEE. This is plate number 1, this is plate number 2, and this is plate number 3. All these plates are going to create electric field at this point. Let me use the color code. This is green, this is pink, and this is my favorite blue. So green electric field created by the first plate will be in which direction? It will be in this direction. It will go away from the plate. Yes or no? Huh? We understand this? Positive plate. Plate number 1 is positive. And the value of this electric field will be Q by 2A epsilon naught. Everyone understand this? Yes or no?
Yes, sir.
Q is the charge divided by 2A epsilon naught. Okay. What about the electric field due to this pink charge? Remember, pink charge is negative, so electric field will come towards At point A towards mean this one. What is the value of this? Don't say negative now because I've already given it the direction. What is the electric field now? Due to this negative charge, it will be 2q divided by 2a epsilon naught. Negative only tells us the direction. Do we understand this or gone? You understand this? Huh? Do we understand this?
Yes, sir.
Then we come to the electric field created by this blue charge. Now remember, this blue charge is positive, so electric field will always go away. At point A, away means like this. What is the value?
3q by 2a epsilon naught.
That's it, my dear friends. You just now remember all these are vectors. So on the left hand side, I have 3q plus q, 4q by 2a epsilon naught. On the right hand side, I have q by 2a epsilon naught. So the net electric field at point A becomes net electric field at point A vectorly becomes minus q by a epsilon naught I. Do we understand this? Do we understand this? Yes or no? No or yes? Gone? Or we understand?
Understood, sir.
Okay, then you have 3 points to prove. I mean, when I say 3 points to prove, that means you have point B, C, and D to find out the electric field, and you will get exactly 3 minutes to do it. 1 minute for 1 point, and I'll wait for your answers. Do not chill out. Solve the question, get the answer, then stay happy.
EB is equals to 0, sir. Sir?
EB equal to 0.
Yes, sir.
How did you get it, sir? Tukka, sir, or logic, sir? EB is 0, correct.
But
I give you that one. EC?
minus 2q by a epsilon naught I cap.
That is correct. What about D?
Doing, sir.
Good. I hope everyone is doing it.
A epsilon naught I cap, sir.
Q by A epsilon naught I. That is correct. Good. Good. Anyone else got the answer or only one girl? Anyone else got the answer? Sainath says Q by A epsilon naught I. Which point, Sainath? A, B, C, D, which one? A, I have already solved. Point D. That is correct, Sai. Good. Point D is correct. All of you got the answer, yes or no? Eh? Boys seem to have been lost.
Yes, sir.
Everyone got point B?
Sir.
Point C?
Yes,
Point
sir.
B. How are you supposed to get the electric field at point B? I will do it quickly. At point B, the green field is the field due to 1. It will go like this. You already know the value. Q by 2A epsilon naught. The pink field will be, which is the field due to the second plate. It is going towards, so it will go like this. You already know the value. 2Q by 2A epsilon naught. The blue field, which is the field due to the third plate, will go like this. You already know the answer. 3Q by 2 epsilon naught. This green and pink field will be equal to the blue field, and therefore the net field becomes 0. Do we understand this? Yes or no?
Yes, sir.
Then moving on to point C. Point C, the green field will go like this, away. The pink field will come like this, towards. The blue field will go like this, away. Away and away will get added up, and you subtract the towards field, and you get the field. At point D, my dear friends, the green field goes away. The pink field comes towards the negative charge, and the blue field goes away. Away and away can be added up. Subtract the towards one, and you have the answer. Everyone got this? We understand this?
Yes, sir.
So why the voice is coming so low, sir? If you understood, then you must raise your voice. Yes, sir, I got it, sir. What? What was it?
Yes, sir. I got it, sir.
Simple question, sir. And then you talk things, sir. Give us a now tough question, sir. I'm looking for a tough question. I'm not getting it. Anyways, if you understand this, this is good enough. I don't have to do anything else in this. Let me just give you, as I told you, what did I tell you? That I'll give you the general formula of that sheet. So we'll do this one, and then I'll give you the general formula of that sheet. So, and I don't know whether you have done this question or not. If you have done it, is good. If you have not done it, then also is okay. You have to remember the results of this so that you can do it if it comes in an examination hall. This is the problem, a thin infinite sheet of width W. Width W? What does that mean? That means this sheet is infinite only in one dimension. It is infinite along the length, along the width, it is having a width W. So it is infinite sheet only in one dimension. Do we understand this?
Yes, sir.
You have to find out the electric field at 2 points. One is the electric field at this point P, which is I think at a distance D from the edge. And the other one is a point in the plane of symmetry at a distance D. First, let us find the answer for this one, and then I'll tell you which answer are they asking for. Which question are they asking for? So let us first find the electric field at this point P. Anyone knows how to do this? Anyone knows how to do this? Now remember, how you got to do this is you will have to break this sheet into small parts. Into small parts like this. Each small part will have a thickness of delta x, and this small part will be at a distance x. Now this small part will become an infinite wire. The small part will become what? An infinite wire. And then you will have to find out the field due to this wire. All the electric fields will be going in the same direction. If it is a positive sheet, all the electric field will be going in this direction. So what you do is, once you find out the field due to one line charge, you integrate it and you get the electric field due to all the line charges put together. From one end to the other end, this will require you to integrate this. Let us not get into that part. I will just show you the result. I will just write the result. You remember that result. Okay? Do you understand how this is done? As such a question comes in the examination hall, you will not have time to set up the integral and solve it. What you need to understand is, if this question comes, you just remember the result, and the answer for this one is sigma by 2 pi epsilon naught into natural log of W plus D by D. So you just remember this integral. I don't think this will come in the examination hall. If it comes as a direct question, you just write the direct answer. If it comes as a direct question, you just write the direct answer. Now, what I was more concerned about is the next part of the question. The next part of the question is like this. Now, it might be difficult for you to imagine it. So I can help you in imagining it. If this is your sheet, now what are they asking here is, if this is your sheet and I'm assuming it to be infinite in this dimension, it is infinite in this dimension and it has a width W in this dimension. So this is the width W given to you and it is infinite in this dimension. What are they asking you is to find out the electric field at some point here at a distance D from the plane of the disk. So if this is the distance D, they're asking you the electric field at this symmetric point. Do you understand this? Now, if I turn it like this, and if I show you this diagram, it will look like a line and it will look like a point. Do you understand this? If I show you this diagram, if I show it from this angle, it will look like a line and a point, which is what is given here. Which is what is drawn here in this. And again, this is how it looks. I hope you understand what I am saying. This is how it looks. Point is here. I've turned it like this. Or if this is the width, I'm showing you the front angle. This is the width that you see. This is infinite like this. This is the width that you see. And this is the diagram that you are seeing. One line whose width is W and this point. Do you understand? You are seeing it in 2 dimensions, not in 3 dimensions. So this is how it looks like. Now, if this sheet also becomes infinite in this dimension, this should give you the formula of electric field due to a sheet. Do we understand this?
Sir.
If this sheet becomes infinite in this dimension also, this will become the formula for infinite sheet. Now, you have to remember the general formula. So this is the diagram. Let me write the general formula like this. So I will draw one more diagram here. This is the sheet, and I will not give the formula in terms of width. I will give you the formula in terms of angle. So this is the perpendicular bisector. So this angle is phi. This angle is phi. Perpendicular bisector it is. So the electric field created by this sheet will be given by this formula, sigma by pi epsilon naught into this tan inverse of phi. No, not tan inverse of phi, multiplied by phi, where what is phi? Phi is this semi angle, half of that angle, semi angle. This is the general formula that I wanted to for you to remember. I said now when I was talking about this infinite sheet, I told you that I will give you a general formula for infinite sheet. This is the formula that I was talking about. If the sheet is not infinite in this dimension, this is the formula. Now you can check if the sheet is infinite in both dimensions. If the sheet is infinite in both dimensions, this value of phi becomes pi by 2, because then this angle will become more and more and more and more. Do we understand this, what I'm drawing here? So when this sheet becomes infinite, it's like an infinite wire now. It is extending to infinity in this dimension. This value of phi will tend towards pi by 2. Do we understand this?
Yes, sir.
As soon as you put pi by 2 in that diagram, in that formula, you will get the electric field as sigma by 2 epsilon naught. So that is how you can check this formula. Remember, the electric field due to a sheet which is not infinite is sigma by pi epsilon naught multiplied by the angle phi. That is what you need to remember from the discussion that we had. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
Have you noted it down?
Yes, sir.
Okay. Now, this was a question on sheets. You've done question on this, to do question on that. Okay, then we come to this category of question. What is this category of question? In this category of question, you have sometimes shells and sometimes you have spheres and shells. Now, this category of question will keep on coming till the entire electrostatics is completed, till the entire capacitance is completed. So these type of questions will keep on coming. So this is the first of this type, which is right now coming in case of electric field. So what question you have? This is the question that you have. This is just to again understand a concept behind this. Question number 2, let me call this. Two concentric uniformly charged spherical shell of radius r1 and r2. Achha, this is uniformly charged. So let me first change this question. Don't write this question, leave the space. Let me make my question first, then we will come to this question. So I will make my question first. We will first solve this question, then we will move on to that. Okay. So my question, the diagram remains same, but the language will change. Now, again, you see Let me call this question as question number 4. Again, you see two concentric shells. These are two concentric conducting shells. The inner shell having a charge Q1 and the outer shell having a charge Q2. The radius of the inner shell is R1 and the radius of the outer shell is R2. Now, whenever such a question comes, there are 2 or 3 or 4 different points where they might ask you to find out the electric field. The first point would be your center O. Then there could be this point P, which is inside the inner shell. Then there could be this point Q, which could be on the inner shell. Then this point could be R between the two shells, and this point S, which is outside the outer shell. So these are the 4 or 5 different points that can be made. Okay. Now you have to find out what is the electric field at all these points. The distance of point P, if you want, you can take it as x1. The distance of point Q, you already know, it is R1, so you don't have to take it. You can take the distance of this point as x2, and you can take the distance of this point as x3. Let me call this point as let me call this point on the shell as S, P, Q, R, S. Let me call this point as T. So you have 1, 2, 3, 4, 5, 6 points. And you have to find out the electric field at all these 6 points. And your time
is 0, sir.
Yeah, beta?
Electric field at O and P is 0.
Electric field at O and P is 0. Q, R, S, T.
Q1 by R1 square, sir. For Q.
Okay. R. Okay, I'll give you 2 minutes to solve it. I hope everyone is solving questions. Yes, bacha, do we have answers?
Sir, at R is KQ1 by X2 square, sir.
K Q1 by
Q1 by
X2
X2
square.
square.
That is correct. The next one.
Q2 by R square, sir. R2 square.
Try again at point S. Try again. Remember, you just have to remember.
Q1 plus Q2 by R2 square, sir.
Q1 plus Q2 by R2 square. That is correct. That is correct. Everyone got the answer? Everyone in the class, bacha?
T K Q1 plus Q2 by X3 square, sir.
Correct. That is correct. How are we supposed to do this? We just have to remember. We just have to remember what? What is the electric field created by shell at different points? Now, at point O, if you talk about at point O, let me write it here systematically. At point O, to get the electric field at point O, I must find out the electric field due to Q1, and then I have to find out the electric field due to Q2. But this point O lies inside the shell Q1. So electric field due to this one, electric field due to this one is 0. Electric field due to this one, since it is inside, it is also 0. So the answer is 0. If I move on, anyone understanding this?
Sir.
Electric field at point P, again I have to find electric field due to Q1, plus again I have to find electric field due to Q2. This point P is again inside Q1 and inside Q2, so both of them are still 0. You don't get anything. To get the electric field at point Q, which is on the surface of the first one, I will get the electric field as Q1 divided by 4 pi epsilon naught into R1, and the direction would be I. I'm assuming that this is positive. Do we understand this? But the electric field due to Q2, because this point is still inside the shell, the electric field due to Q2 will vanish. It will be 0. Then I move to point R. Electric field at point R will be only due to the inner shell, not due to the outer shell. So it will become Q1 by 4 pi epsilon naught. It will be R1 square. I've written R1 square. So this will be divided by 4 pi epsilon naught x2 square. The direction would be I, plus electric field due to charge Q2. It will still not come because the point still lies inside the shell. Electric field at the point S, which is on the surface of the second one, now it becomes Q1 by 4 pi epsilon naught R2 square along I, plus Q2 upon 4 pi epsilon naught R2 square along I. The first one is because of the first charge, and the second one is because of the second charge. To find the electric field at the point T, again it will be Q1 by 4 pi epsilon naught x3 square along I for the first charge, plus Q2 upon 4 pi epsilon naught x3 square I due to the second charge. So these are the answers that we have. Do we understand this? Yes or no? Anyone understands this?
Yes, sir.
Okay. Shall we move on to the next question?
Yes, sir.
Okay. Now comes this question, and again we are going to see a lot of these questions, and there is a special condition given. You must understand this condition as well. So a spherical shell having charge plus Q uniformly distributed and a point charge Q naught are placed as shown Find the force between the shell and the point charge. And this condition is given. Can anyone tell me what is the meaning of this condition? R is very, very large compared to R. Small r is the distance between the shell and the point charge, and capital R is the radius of this point charge. Why radius of this shell? Why is this given? R is very large compared to small r. Small r is very large compared to capital R. Why is this thing given? Why is this thing given?
Neglecting the capital R, sir.
Yeah, beta?
Neglecting the capital R values.
No, it's exactly not neglecting. Keep this question in your mind, and once we go ahead, we will try and understand why this is given. So keep this question in your head, why this condition is given. I will answer it at some stage. May not be now. We'll answer it at some stage. Very quickly, not very late. I will answer it very quickly. Yes, what is the answer? Anyone? Okay, I'll give you 2 minutes to do it. Anyone got any answer? No one got any answer. We had done a question like this before. We've done a question like this before in the last to last class, where you were supposed to find out the force between an infinite line charge and a point charge. Does anyone remember this question? In fact, it was the first question. See, question number 1 was written. Anyone remember this question? And then you gave me the answer very quickly. So the answer is lambda by 2 pi epsilon naught r multiplied by q. When I give you this question, which is a lot simpler than the previous one, why is no one answering? Yes. So the answer is, now to find the force because of the point charge on the sphere can be a big task, but the opposite one is very simple. You can find out the electric field created by the shell at this point R and simply multiply that electric field by the charge, you will get the force. The electric field at this point, because of the shell, would be going in this direction, and the value will be Q by 4 pi epsilon naught into R. Yes or no? You multiply this electric field by the charge, so Q naught into Q divided by 4 pi epsilon naught R. This becomes your force applied by the shell on the charge, which should be equal and opposite to the force applied by charge on the shell. Do we understand this? Yes or no?
Yes, sir.
So that is how you must do it. This R is given very large compared to R for two reasons. The first reason is, if this R is not very large, because of the presence of this charge, the distribution of charge on the shell will be different. That is the first thing. And the second thing is, when the distance is very large compared to the radius, when this distance is too large compared to the radius, then you can take the shell also as a point charge. So these are the two reasons why this was given. I hope you understand this. Everyone understands this?
Yes, sir.
Okay. Now we can move on to the next question. And if you understood the concept here, you should be able
Wait
to.
for 1 minute, sir.
Okay. You note it down, don't worry. I will give you time to note it down. Remember, beta, the time that we have is very limited and we should make the most of it, whatever time we are getting. You'll get a lot of time to chill out if you get into an IIT. No one studies there. So if you can study now, you can have a jolly good time afterwards. But if you
Sir.
chill out now, then you will have a problem. Okay. This is the next problem that I am giving you. Find the force between two shells of radius R1 and R2, which have uniformly distributed charge Q1 and Q2. Distance between their centers is R. Again, the condition is not given, but you must consider that condition. This small r, which is the distance between the center of the shells, is very large compared to their radius R1 and R2.
A Q1 plus Q2 by smaller square, sir.
Yes, bacha.
A Q1 plus Q2 by smaller square.
Q1 plus Q2. No. To find the force, why it is plus Q2? K Q1 Q2 upon 4 pi epsilon naught r square. Isn't it?
A Q1 plus Q2. Q2.
The force between these two shells will be K Q1 Q2 by R square.
R square.
Not Q1 plus Q2. Do we understand this?
Sir.
Pakka? Okay. Everyone understand this? Yes or no?
Sir.
Now the next problem that we are going to do are very popular. This has come in JEE couple of times. There is a variation of this problem which has come in JEE recently. At one point in time, every year, a problem of this type was coming. You never know it can come. When I say JEE, I mean JEE Advanced. So this is the problem. A uniformly charged, solid, non-conducting sphere of uniform volume density rho and radius r is having a concentric spherical cavity of radius r. Find out the electric field intensity at the point shown. Point A, point B, point C, point D. Whatever it is. Now, the question is in front of your eyes. You have pen and pencil. Attack! You have 3 minutes to attack. 1 minute per question. 4 minutes. Get the answer. Stay happy. Yes, bacha, shall I help you? Huh? Or you can manage it. Any idea how we are going to do this? Yes or no? No, yes? Shall I help you? Yes, Bacha?
Sir, can you give small hint?
Sir, can I give you small hint? Yes, I can give you small hint. Not a problem. See, there are different variations of the question. Now, if I have to start giving you hints, I will have to probably take you back, 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 take you back. Where? To this point here. Do you see this non-conducting sphere? And we had calculated, I had given you the electric field at various points. Do we remember this question? Do we remember these formulae? Okay. Now here the formulae were given in only the magnitude. It would have been better if I would have given you this formula in the vector form. Now, what do I mean by this formula in the vector form? So I hope you remember this formula. Yes or no?
Yes, sir.
Let me take you back. Let me take you to the present now first. And if I take you to the present, I will show you a diagram. Let me get a diagram from somewhere. First sphere, where is this sphere? Can I get a sphere from somewhere? Can I get a sphere from somewhere? Okay. Can I get a sphere from somewhere? There's no sphere I can find. Okay. Now I found a sphere. So this is the sphere, right? Okay. I found a sphere. This is the sphere. Now this is a uniformly charged sphere. The charge is uniformly distributed throughout the volume. Now, if I take any point on this sphere, let us say here. If I take any point on this sphere, let us say here. At a distance, let us say small r. You remember the formula for that electric field inside that sphere, right? What was the formula? What was the formula? Huh? What was the formula? Electric field inside the sphere, what was the formula? I just showed you that. No one remembers it? Go back and tell me. What was the formula for the sphere that I told you? No one remembers it. That is the problem. Remember, beta, you'll have to remember a lot of things while you're sitting for the exam. If you forget it, that's not a good thing. You just said that you remember it. What was the formula? Huh?
AQR by R cube.
But I told you that I don't remember it in that way. The way I remember it is in this form. Electric field is rho r by 3 epsilon naught. Did I tell you that?
Sir.
Now, you know the electric field at this point P is rho r by 3 epsilon naught. What will be the direction? Now, because of symmetry of this everything, we can understand that I can write this electric field in this vector form, where r vector is this vector which is going radially away. Do we understand this? So electric field goes like this. At any point inside the sphere, electric field is always going radially away. Do we understand this logic?
Yes, sir.
Okay. Now, whenever you get a problem, whenever you get a problem in which you have a hole, And I told you, you will get problems where you have a hole. है ना? I gave you a problem, na? Disk with a hole. And I told you how to find out the electric field due to this due to a hole. Yes or no? Do you remember it? This one. The disk had a hole of radius small r, and I told you how I would do this. Do you remember how did I do this? Yes?
Yes, sir.
Or no? So what did
Yes,
I
sir.
do? I broke it up into two particles, two bodies. One is the complete disk of charge density sigma. Then I put a disk of charge density minus sigma. Yes or no? To create that illusion of hole. The hole here means simply that there is no charge. So I not create charge. I put a positive charge, complete, and then I put some negative charge so that the beach wala charge gets gayab. That is what you got to do. That is what you got to do. That is what you got to do in this entire question. How will I find the electric field? Not this one. The question is here. This one, cavity. How do I find the electric field at point? Obviously, we understand that electric field at point O is 0. Whatever happens, electric field at point O is going to be 0. You just have to find out the electric field at point A. You wanted a hint? I have given you the hint. Right below, you see electric field written in the vector form. You wanted a hint? I have given you the hint. Do you want me to solve the question for you? Shall I do it?
Yes, sir.
So what will I do? I will first assume that this is a full sphere. I'll assume that this is a full sphere. So the electric field at point A, it is a full sphere made up of uniform charge density rho. So electric field at point A, and remember I will write it in the vector form so that everything takes care of itself. It will be rho r by 3 epsilon naught, where r is the distance of the point A from the center O. Yes or no? Now, how do I create the illusion of this negative charge? How do I create the illusion of this hole? So I will put a negative sphere of charge density uh, here I have used r. The radius of this was r, so let me not use r here, let me use x here, because if I use r for both you will get confused. So let me use the distance as x, because r, small r, is given as the radius of that sphere, radius of that hole. So now I create this negative row and put it there. If I put this negative row will cancel that positive row, and the net charge will become 0. That will give the illusion of this hole. So what will be the electric field due to this blue one? Electric field due to the red one is rho x by 3 epsilon naught. The electric field due to the blue one will be how much? Same thing but with a negative sign. Yes or no?
Yes, sir.
So what will be the total field at point A? The total field at point A will turn out to be 0. That is the answer for the first part. Do we understand this, or this has gone above our head saying bye bye sir, this is enough? Enough I had. Now no more. Huh? You understand this, or this is gone above it saying bye bye, sir, bye bye, bye bye, bye bye. Chalo, I solved this point A for you, point B, point C, and the center of the sphere. Center of the sphere also we understand this. So I have done point number 1 and point number 4. Yes or no? No, yes. Huh?
Yes, sir.
So I solved A and center O for you, my dear friends. B and C remain for you. How do you do this? You just apply the same logic, get the answer, and stay happy. In the next class, that is tomorrow, I will shift this hole somewhere else. And that is the question that came in JEE twice. And that is the question taken from Mirodo, where this hole is not concentric, hole is somewhere else. Huh? Can you find out electric field at point B and point C?
Trying, sir.
Trying. Try is good. Now remember, point B is outside the inner sphere, the negative sphere, but it is inside the outer sphere. So remember, for one sphere it is outside, for one sphere it is inside. The first point A was inside of both the spheres. But for second point, it is outside of one sphere and inside of the second sphere. I hope you understand what I'm saying. So I'll give this one as a homework for you. In the next class, we will be winding this finally electric field. Then we'll be moving on with electric lines of force, which comes from this electric field. And then as soon as we are done with electric lines of force, we'll start with your favorite topic. That is Gauss law. So Gauss law is coming up, loading in the next class. The must awaited Gauss law, which everyone is waiting for. I don't know why, but yes. So that will come in the next chapter. As soon as we do Gauss law, we'll probably finish about half of electrostatics. About half, excluding capacitance. So we'll do about half of electrostatics. So congratulations on that front also. That means life is going good and we should be able to complete your electrostatics. If everything goes fine, probably by the end of this week, next week. I mean, this week, next week, we will be completing your electrostatics, and probably by first week of December, we must be done with your capacitance as well. Next week, electric current. Next week, magnetic field. Next week, EMI. Next week, AC done. Entire December, your entire electric field will whoosh, and your entire course will be done. Then only modern physics will be left. Whatever is left, I'll complete that one also. So by 15th of Jan, you would be clear cut heroes from my side. Okay, then I'll see you tomorrow. I hope you give me the answers for this one, point B and point C. I hope to see those answers with you. Take care. Have a nice day. God bless all of you. Take care of your health. The climate is changing. Do take care of your health. My son just got fever today, so I'm concerned for all of you as well. Take care. Do not roam around here and there. Bye-bye.